All right, question number 6. We want to evaluate the following limit at infinity. So we're finding the end behavior as x goes to positive infinity of 3 plus 6x plus 6x squared over x squared. Okay, so the key here, we want to focus on the denominator and the largest exponent here, and we want to see what's going on with this function. So we're going to divide each piece by x squared and see what's happening as x gets big. So we'll think about this as 3 over x squared, 6x over x squared, and then 6x squared over x squared. And then we have x squared over x squared. All right, so each piece at a time, I'm thinking about this first function. As x gets really big, this whole thing goes to 0. As x gets really big here, one of the x's will cancel out, so still 6 over x. The bottom is getting really big. 6 is staying constant. This whole overall fraction will be going towards 0. Here, x squared and x squared will divide each other out, and so we end up with 6. And then same thing, divide each other out, and that's just equal to 1. So at the end of the day, 0 plus 0 plus 6, we end up with 6 divided by 1. And so we would say that this overall fraction is tending toward 6. And that would be the same thing if you think about the degree on the top and the bottom. So if we go back to this scenario, the top and the bottom are equal. So the ratio of those two would tell you what that horizontal asymptote would be. And so the x squared with x squared, this is understood to be a 1. And so 6 divided by 1 is giving us the 6. So at the end behavior, this graph is going to be flattening out, going towards 6. Number 7, we want to look at the end behavior of the exponential functions. And so the first one, we're looking at the limit as x goes to infinity of e to the x. So just think about what that graph looks like. It is curving up and going to infinity, e to the x. So as x is going to positive infinity, this graph is shooting off to positive infinity. You can also just use a graphing calculator and plug in some numbers. What happens when we take this graph and we go to negative infinity, so going the other direction, okay? This graph is going towards 0, and we have a horizontal asymptote here. So part B, as x goes to negative infinity, ex, we just go to 0. It's going down, down, down to 0. You can also see those properties in the textbook. And then we think about what happens as we think about the limit of e to negative x. So think about what happens if we make x negative, this graph gets flipped across the y-axis. So when I'm thinking about the limit as x goes to positive infinity of e to the negative x, that graph just gets reflected across the y-axis, making the x values change signs. So as we're going toward positive infinity, we're just going to be going to 0. So just taking this graph and flip it.